Well, hi, and welcome to my shop for another day on this gigantic radio, but it's a good day. It's a good day because the last video ended with me making this radio work to some degree, anyway, to a fair degree. And that reassures me that major components are okay, coils in particular and things like that. And there could still be trouble in there that I haven't come across, but generally speaking, I'm in a much more comfortable position now with this radio. And what is that exactly? That means I can go forward, make component replacements, and if I boob up in making a component replacement, when I subsequently test the radio, I will realize that, hopefully. If the radio is not working and you go ahead and start replacing all these parts and you make mistakes, now you've got the problem of the radio not working and your own mistakes in there. Yikes. So that's very much what I'm trying to avoid. And the key to it is having the radio work to some degree. So lucky I'm in that situation now. So now there's a lot of big capacitors in this radio. Look at them all up there, and they're all going to be replaced. Let me just take a look at this one. It's a 0.1 microfarad capacitor. That's a fair size capacitor. It's a little expensive as compared to even smaller capacitors, and my stock of large capacitors like that isn't the greatest. But what I do have is a fair number of, in fact, 0.1s at a lower voltage, 100 volts or 200 volts. So I'd like to know if I can utilize those lower voltage capacitors in this radio. Just looking at it, I can see the capacitor rating here is 400, but that doesn't mean an awful lot in terms of what the real voltage is that the capacitor's subjected to. So if I knew what the voltage was across each of these capacitors, I could make a wise choice as to whether to put in a 600 volt capacitor or a 200 volt capacitor. And how can I do that? So my little brain has come up with two ways of doing it. One is study the schematic, figure out from looking at the schematic what capacitors typically have lower voltages across them, then identify them in the radio, and then make the replacement. Seems to me that's a long road to hoe, and the result is I probably get things wrong anyway. A far more direct approach would be to simply measure the voltage across these capacitors. Now, the radio is not working in a normal way in the sense that I'm not powering it through its own power supply. And I can't do that as long as I don't have the original speaker. Or it's wiser for me to not try that without the original speaker. So consequently, what I'm doing then is I'm ignoring the power developed in the radio itself. I'm using my power supply up in the back there, this guy up here, to provide the B+, and I'm allowing the transformer in the radio to supply the 6.3 volts for the tubes and the lights. And under those circumstances, would it not be the case I could still measure the voltages on these capacitors and determine which ones are being subjected to higher than I think 100 volts is really what I need to look at. I guess I better check my capacitor stock for their ratings, make sure I know what I got before I do this. The overall B+ in this radio, from what I can see on the schematic, is at maximum 260 volts on some plates of some tubes, especially the output tube. So 260 is the max, probably right on the power supply. Well, actually, come to think of it, it's shown right on the power supply main filter capacitors, these guys down here, to be 260 and 300 are the two numbers that appear. So what that tells me is if I'm supplying a couple hundred volts to this location down here and throughout the radio, I'm in the ballpark for the normal B+ voltage. So if I take readings with the external power supply, should still be reliable. So you're listening to me explain all this stuff as usual. It sounds like I'm telling you, but really I'm just going over it for my own sake here. To try to uncover any errors or stupid thinking that I might be doing. Okay, so we're going to go ahead and we're going to start measuring these guys. I'm going to start the radio up. So first thing is applying the 6.3 volts. Okay, I don't think there's too much to be worried about here. How come it didn't come on? So I think I'm on a band that doesn't have a light. It's always nicer when you have a light come on or sound come out of the speaker to keep you constantly reminded that the power's on for the thing you're working on. Okay, so I can see a filament has heated up. Okay, so that means the tubes are hot. I'll warm up my power supply here. And in the meantime, take a peek at my capacitor stock here. Oh, 0.1. 0.1. Dropped one. Okay. So these yellow guys are 630 volt capacitors. They can pretty much go anywhere in a radio like this without even thinking about it. These green ones are 250 volt, 100 volt AC, 250 volt DC. So normally the black here would yeah, I was going to say this can't be electrolytic, can it? No. So that's what I thought here. Brown one. Oops. Brown one here. So this is it says 160 volts. 100 volts AC, 160 DC. Same thing. Okay, so 160. So if I can find capacitors with 150 volts or less across them, those become ones that I can put in a lower ranked capacitor. Let me change the lighting here in my shop. You can see the meter over here a little bit better. Maybe if I just do that. And seeing in the back of the radio. Okay, time to raise the B plus now on it. I'm going to measure it as I raise it. Measure it right down here. Better turn on the meter. That would always help. Okay, ready to start here. Is my meter just warming up? Okay, she should be ready to go. So I'm on the 500 volt scale, so we're looking at raising this up to about here. Give us 200 volts into the radio. You know what? Why don't we turn the sound on here too? Yeah, that's a good idea. In case. Okay, and I'm still picking the audio off for that little speaker you saw from the grid of the tube up here. Okay. Now, what happened here? What happened here? This just came off. Don't want this coming off. Is there a better spot for me to clip it? This really is the best spot. Anyway, so I don't like that spot. Anywhere along the B plus line is going to be good. That's popping off here. Let's just make sure these are more secure. So it's coming up here, right to here. So I can actually clip this. It's kind of an awkward spot right in the middle here, but that's really, it's pretty secure. Okay, I'll put it over the top here. Wait a minute. It's a little bit tangled up. Let's untangle stuff. Put this up here. Oh, son of a gun. Make you jump. Made me jump. Just plugging the cord back into my amplifier. Okay, jumpy is definitely a good state to be in doing this kind of stuff. Radio's on with no B+. We'll raise the B+, maybe some sound come out of the speaker. Like raise the Titanic. Raise the B+. 50, 60, 100. Ooh. Let that soak in. It's 100 volts according to my power supply meter. Slowly, slowly the current is relaxing to 30 milliamps again. Okay. And the speaker just went. Where'd the sound go? Okay, I want to go a little higher on the voltage here. We're at around 100. Let's measure it down here. So we're measuring, that's a 150 volt scale, we're at like 90 volts. That's just not enough. Okay, now let's see if we can do all this at once. That's 150 volts. Oh my gosh. Guess what there? What's he saying oh my gosh about? He didn't quite, you can't see it, but the way my lighting is here, there. So the current meter here, just now I looked up and it was pinned right over. Can't have that happening. Not exactly sure. Sound disappeared. Current went high. I don't think the current went high when the sound disappeared. So I think I still have, well, what have I got on there now? 50 volts. Why did the sound disappear? Let's see if we can sort that out first. Did something fall off? No. The volume was turned right down. Okay, be more and more B+. Just watching this 50 milliamps now. You get up to a certain voltage and away she goes. Current wise, this is a tiny variation in voltage right here. It's making a huge variation in current. What exactly would be doing that, I'm not sure. You know, it's like fluid reaching the top of a container and flowing over. The flowing over part. So I'm filling something up to the point where it's flowing over. Well, there's nothing like that in a radio. So I think it has something to do with tube bias. I don't really know. Let's go a little higher yet. Oh, just tiny advances in B+, big changes in current here. Well, let's set it where I think it's safe, about 35 milliamps. 35 milliamps gives us a voltage of, okay, 120 volts. That's way low from what it should be, but let's go with that. So we're half. So conceivably every voltage I measure would normally be double what I'm getting. That's kind of a rule I'll have to follow here. This may not work in the end. Another good idea that's no good. Oh, that's not very good. Give me some interesting lighting here. Yeah, it's like a scary lighting. Okay, here we go. So grounded, other side on this one is, and what am I going to do with this information? I'm going to mark those. So all the high voltage, should I mark the high voltage ones or mark the ones that show low voltage? So the rule will be anything that goes over 50 volts is going to take 100 when the set is running. So I'm looking for 50 volts, and then it's replace it with a smaller capacitor. 50 volts is right in here. Anything over this point, and I got to use my expensive yellow capacitor. So for instance, this one. Oh my gosh, my hand is really awkward here. Do it less awkward. So so that's well over the 50. So this would be a high voltage one. So I put an H on this. What should I put on there? I should put an X, a check mark. X, what's X mean? X means don't put a small one in there. I'm going to write the voltage on here because if I don't, so we'll say this is above. This is above. It's too high. This is okay, big X means don't put a low voltage one there. Don't put a low voltage one there. That's what that means. Okay, I think I got the method here. Let's go on to the next capacitor, this white one. Okay, let's try it again. So the other end, one end is grounded, and this side is suspiciously, it's negative. It's actually a touch negative, but it's tiny. So this one we could replace with a small guy. That's a check mark. This is a mistake, putting check marks and X's. Next guy up there. He's also on the ground. The other side. Ooh, 50. So this one you could do. You could do this one. The 50 is probably 100. I have 160 volt. Oh, that's a terrible check mark. Okay, next one. This one side grounded, other side is on here, right here. That's all. It's no, don't put a small one in there. No small ones. Okay, so here's a couple more capacitors here. One side grounded right to the chassis. The other side, you gotta look really careful here. I'm gonna have to flip on more lights. Again, the lighting in the shop looks different on the video than it is with my eyes by a long shot. Sometimes it looks okay on the video. It's actually quite dark in here. So it's these two. Okay. That guy. Nothing. Now you might say, wait a minute. The problem here could be one of these capacitors could be shorted. And with a short, you're going to read no voltage on it. True. So when you read a 0, you got to think about it. So this capacitor comes to this terminal. There's no 2-pin in this terminal. This terminal's spare. So there's a wire coming from it, and who knows what's going on now. The wire comes over here. So what are the chances that that's a shorted capacitor grounding out that wire? Extremely low. I think extremely low, because the radio worked to some degree. That's my theory at work. So this guy, he can be done with a low guy, low voltage. Check mark. How about this big one? It's the big ones I'm really worried about here. It's the small ones I don't really care too much. Okay, that's right on this terminal here. No voltage again. Really? There's no voltage? Why is there no voltage? That's the B+, so there's definitely voltage in the radio. Double check and make sure I'm on the right terminal. Yep, nothing. So he can go. The great big thing can put a much smaller, physically smaller. Oh my gosh, that looked like an X. I knew using check marks and X's was a mistake, but I went ahead and did it anyway. Okay. Check, check. Now here's another one. Little one down here. No voltage again. Isn't that kind of mysterious? Do you think maybe I have switched the band switch, suddenly voltages would appear? check mark. So here's one here. One side right to the chassis. The other side, this capacitor appears to be in bad shape. Gain nothing. By any wild chance. So currently the automatic frequency control is switched on. If the switch is good, I don't think there's any voltage involved here. No. I'm just surprised to find all these capacitors showing 0 on the high side. It's not really 0. I guess if I put the meter more sensitive, maybe we'd see it's 10 volts or something. So you don't need all these super high capacitors, high rated capacitors. Here's another one over here. This guy's going here. Again. Really? Every time I do that, hey, is your meter working? It's working. I just sort of, I've never done this before, so I always assume all these capacitors you see are all taking the big voltage here. Well, I really went on to this one. That's it so far? Only 2 of them taking the beating. Okay, there's more big ones. Here's a big one here. And it's hooked up to this point here. Wait a minute. 2 capacitors on the same point? Both capacitors go to the chassis, and the other side they both go to the same pin. That does not make sense, does it? 2 capacitors, both going to the chassis, both going to the same pin. That doesn't make sense. I gotta be seeing this wrong. I don't think so. Stick your finger in there. Don't stick your finger in there. Well, let's see what's on them anyway. Wait a minute, this isn't gonna work. So, assuming they both go here. Holy smokes! Hey, I fixed it. It's fixed again. Quickly, somebody explain that to me. I chuckle. Well, okay, so I'm just letting myself recover a bit. Is that a little bit of adrenaline shot there? Let's turn down the radio. Glad I had the speaker hooked up. So I have had a lot of experiences similar to that over the years. Many experiences where tapping a terminal seems to alter something. Something comes into life. Something comes to life. Just like that. Just like I did. And I've always assumed what it is some kind of tiny little short circuit or some kind of tiny little open circuit that can be overcome very easily if somebody does something. Now, what exactly would you do? It could be anything from any kind of mechanical motion to, I don't know, shocking the system electronically somehow, and I don't know, getting electrons to fuse a point. I don't know. What do I do here? I think I put the voltmeter down and we get out the stick. The almighty stick. I think I fixed more radios with a stick than almost any other single tool. So I'm going to poke around there. We'll see what happens. It's right here. So that's how much contact I made. I mean, I barely touched it. So mechanically, I don't think I did a darn thing to this radio. And you got to wonder, I mean, this is a high impedance thing. There's just no electrical business going on with it really at all. I'm going to push on the 2 pin a little bit. I'm going to wiggle these wires by prying on them. It's a very, very controlled way to wiggle them. Nothing prying there. I'm trying to set up, what do they call this, a Class A lever, Class B lever? Isn't this kind of weird? Now it's really close to shorting right in here. So I just moved that whole terminal, went up and down, this wire moved up and down, nothing happened. It was just a wild coincidence. I happened to touch that terminal. Touching that terminal sent some kind of shock wave through the radio that tipped off one of these things I was talking about. Gotta love it. Okay, so let's see what the voltage is there. Anyway, just trying to keep my hand out of the way of the meter. It's really, really noisy. So somehow this thing is influencing a grid on a tube or something like that. Look at that. I'm getting close to these coils. An interesting discussion with somebody on email about these coils and the braided wire here and why it's done. You see that? These two larger coils have braiding in the wire, but these ones down here don't. They don't bother with it. So the braiding is very useful in the lower frequencies. It doesn't help much at the higher frequencies. So, and what does it do? It affects the capacitance between the wires. That's the main reason why it's braided. And in fact, even though this looks like a single conductor insulated wire, this could be multiple conductors insulated against each other and cabled, very, very tiny, and then wrapped around here. I don't know. That's not. Let's just say you don't want to damage these guys at all. Well, these coils are. When you look at a radio like this, you see the tubes and the stuff up on top and all that. You think, wow, that's really cool. This is actually where an awful lot of the coolness exists, in these coils. These designed, engineered coils here. Now, have I forgotten totally what I was doing? So, noisy spot here. So, clearly it's sending an influence through the radio because it's going all the way out the speaker. So, somewhere in that chain is one of these little, almost in contact things. I don't know. Maybe it'll go away again. Maybe we'll get a chance at it. And what did I read for voltage? What did I read for voltage? I'm just too excited here now. The crazier it gets, the more excited I get. So that's 50 volts. So yeah, these ones can also be replaced with lower voltage capacitors. You can also see that the building of this radio has followed a rule about each of these capacitors. You see how the big capacitor has a band right here? See a band right here? Whoops. Right here. This one's really clear. You can see a band at one end. Band. So that banded end is the end you connect to low impedance or to ground if you can do it, which is basically really low like this. Banded end to ground. Banded end to ground. All the way around here. They're all done the same. The banded end is indicating which lead on the capacitor connects to the foil that happens to be wrapped on the outside. You know, like the two pieces of foil are put together with a dielectric in between, and then they're curled up. I can't curl up my hand, but then they're rolled up into a tube and stuffed in here. And then inevitably one of those two plates ends up on the outside of the capacitor. Outside foil. What's the significance of that? If you hook the outside foil to a ground like this, then in a sense the capacitor is shielded. Its own plate is shielding it. Anyway, something to consider. Well, they certainly took care of it in this radio. Every capacitor is done that way, as you would expect. But if you look at newer capacitors, not marked. Not marked on any of these. But if you look at these are a little older. These ones are marked. Outside foil. I just have to follow the pattern when I go to replace them. Okay, I saw another capacitor right here. And surprisingly enough, that guy's got the full brunt on him. So the full B plus is sitting right here, right there. So this guy gets an X. And there's another one way up in here. Again, one side right to the chassis. The other side. Uh-oh. What was that? Uh-oh. What was those? Okay, opportunity here. Gotta take it. When it comes, you gotta take it. This is a method for chasing out spirits and bad influences from the radio. Nothing whatsoever. Okay, what about the general overall? I heard that. I thought I heard that. Okay, down here. I don't know. Okay, I'm not going to poke at those coils. Could be band switch. Could be the band switch. Could be the band switch just settling in and out. Let's give it a little wiggle. Okay, so where would you find a place in a radio where you could have a contact nearly made but not quite, and then some little electrical effect alter that contact? It could be in the switch, where the switch blades are touching but not really, sort of, and they're so close together, there's a tiny little bit of dirt between them, who knows what's going on there. They've almost turned into a semiconductor. Along comes a little burst of electricity. Could have been the band switch. Could be the band switch. Could be so many things. Okay, back to capacitors, and I never quite got that one red, did I? Did I get that one red? So that comes out. Kind of a weird arrangement here. Okay, nothing. So that one is okay. Any more of these guys? Paper capacitors is what I mean. Just up in the upper area. Just up in the upper area. Okay, I think this radio is ready for a real good cleaning. Get rid of all those and replace them all. Okay, so I've been working along replacing all these capacitors. You can see all the dead soldiers here. The big ones. I'm mostly going after the big ones right now. And I've turned the camera on because I've encountered something that's just a little hard to kind of believe. So this capacitor is one I just installed, and I'm about to do another capacitor. I've removed it. It was here. It was right here. These two capacitors go to the same terminal on this tube. And the weird part is they both go to the chassis. So it's basically two capacitors in parallel on this pin going to the chassis. One is a 0.5 and the other one's a 0.1. I was just getting ready to put the 0.1 in when I said to myself, well, why would they do that? Like, why would they do that? Is this correct, or did somebody do something here? Let me show you the schematic. Well, let's look at the wiring diagram instead. So this is the tube I'm looking at, the tube base, if you like, and this is the terminal. And here's one capacitor, and here's the other. And they're both tied to the same terminal, and they're both going to ground, as they call it. I mean, soldered to the chassis here. The actual location is different than in here. This capacitor is actually located up this way, and this one's located, well, pretty much where you see it, maybe over a little further. This is a 0.5, this is a 0.1. This is a 0.5 200 volt, this is a 0.1 400 volt. What are they doing here? So I mean, ultimately they're getting 0.6. Maybe technically they needed 0.6 here. Seems odd to me. But, and I guess a 0.6 capacitor, I don't think I have such a beast. 0.06, but not 0.6. So maybe this is how they got there. They just paralleled these two to get to where they needed to go. I don't know, it seems like a strange thing to me. But I will carry on with what I'm doing. I just thought you get a kick out of seeing that. Maybe just another little piece of interest, but this is the terminal I tapped on with my voltmeter when the radio jumped to life. Who knows? Okay, so I got a lot of the capacitors done, not all the big ones yet or anything, but I think I got enough. I want to test the radio. But before testing it, I'm going to test these capacitors and see how bad they really are. We'll start with this guy right here. My guess is this one's in good shape. 0.1. So what I'm doing is I'm applying a DC voltage to it, and then the amount of current that leaks through the capacitor should be 0. If it's 0, the eye looks like that. If there's some amount of current, small amount of current leaking through this, the eye will be closed or partially closed. A lot of Kefir on me here. So first 50 volts. Watch the eye. See that pop right open? A little better. Is that better? A little bit better. I guess that'll do. Here, we'll try it again. Watch. Pop right open. 250 volts. Pop right open. So this is actually an okay capacitor. I really shouldn't have bothered changing it. I kind of knew it. My experience with these ones is really good. Look at how rugged this is. So don't jump in and change those. Now let's go to the other extreme. Not really another extreme. This is a big one, 0.25. Back to 50. volts, what do you say? So the eye is not opening. Now this is a big capacitor, so I got to hold this for a while and give it time to charge. Now the eye is not going to open. So this one is completely the opposite from the first one. This one is definitely leaky. Now would this drag the radio down? Not necessarily. The leak can be very small and unimportant. It depends what the service is the capacitor is providing. For instance, if the capacitor is blocking DC from getting to a grid, a small leak would be big problems. In other cases, small leak doesn't mean a thing. Here we go. Looks like it might open. Maybe. It's just no. Okay, so this is typical. You know, this is from these capacitors are from 1937. They're probably made 1936. You know, that's a long time ago. There we go. Chances are, I would think, big capacitor means everything inside it is big. You know, big big foils, big, lots of surface area to leak across. So maybe it would be the case that a bigger capacitor is going to tend to leak more. That makes sense, doesn't it? Not much wire there. Okay, man, how you doing? How you doing? It's going to open a little wee bit. You can't see it in the camera, but the eye has opened a tiny amount. But this is only 50 volts. Yeah, it says 25 there. Don't believe it. It's 50. These things can't stand up to 50 volts. That's not quite the right way to say it, is it? I mean, they're standing up to it, because these things have something called a withstand voltage. That's not at all what I'm doing here. Okay, how about you? You're a dud too. Yeah, so good thing I'm changing all these, of course. It's only been the very odd radio I have had, and certainly maybe not as old as this one, where wax paper capacitors were all in good shape. Now, how did that happen? The radio must have lived an exceptional life for that to happen. She's a duddin'. Doesn't work. There's another one. This is a smaller one now. Smaller one, but this one was had the B plus across it. You would think maybe if it's subjected to pressure during its life, it wears out sooner. I don't know. Here we go. She opened up pretty good. 150 volts. Not going to open. So a brand new capacitor, I've demonstrated this a number of times. You put a brand new capacitor in here, you can crank this up to 450 volts and that eye pops open. So there's no question the instrument is working. And why don't we just prove that? Hey, I happen to have a capacitor right here. Let's see. This is a NOS, I think. New old stock, but I don't think it's that old. Let's see. This is what I'm putting in the radio. This would better test good. This doesn't test good. Got egg upon my face. Here we go. Right open. 150 volts. This is as high as I can go with this capacitor. You see the eye just pop right open. There we are. Watch it now. I didn't let it discharge, so it could have like 100 volts on it or something. Okay, that's the story on the capacitors I removed. Only one I could have left, and still felt good about things. Now we're going to turn this guy on and make sure it can still operate. Okay, so I'm going to put the B plus line back on. Where did I clip it last time? I clipped it way up here, didn't I? I clipped it right on here. B plus supply. Get some tools out of the way here. I like to straighten up my bench just a little bit before I turn things on. If you don't, periodically do a little straightening, next thing you know, you've got a heaping pile of tools everywhere. And then if some kind of disaster starts, you can't react properly because the scene is too complex. We need to remove the complexity here. The main thing is to remember where the exits are. Oh yeah, we have to hook this guy back up. Okay, so he's going on. I could put him right here, in fact. This is kind of the output of the volume control heading to the grid of the first audio tube. Is that going to work there? Keep an eye on it. It's going to short. It depends where I put this lead. This one I can go right here. Okay, I don't think that's going to go anywhere. Good. B plus audio. Make some measurements just to prove the B plus has gotten there. Okay, stand by on the B plus. Okay, we're going to turn on the 6.3 here. Volts. Swing. She's on. Turn on the amp here. And we're ready to start applying B plus. Okay, maybe the amount of current leaking in this radio will be less now. Only a couple of these capacitors were facing B+. This one and this one. And, not this one. Not this one. Just these two. So how much less leakage could there possibly be? Nothing. Here we go. And we should be able to hear something coming out of the speaker here. Okay, raising the B+. 50, 60, zero current flow. Why zero current flow? Because I don't have the ground on. Okay, I didn't hook this up. Okay, B+ voltage is 0. Jim is nervous. Okay, try it again. Going up. 50, 75, 100. Well, seems to be working. I think maybe it only seems to be working. I don't think it's working all that well yet. There's no antenna hooked up to it anyway. But that's what I wanted to hear. So the green light's on to continue the process here. Oh, B+ off. B+ off. Speaker off. Great. Great. Okay, so I've just been proceeding along here and things have been going okay. And I just cut this capacitor out of here, this big gray one. And there's some very hard to see print on here, and I think this thing says 50 microfarads at 50 volts. What? And when I look at it, yeah, you know, it has the look of an electrolytic. There's something leaking out of the end of it there. So 50 from this is could be a spare terminal there. How many 50s are there in the radio? So I'm going to take a look at the schematic here and see what we can find. So the capacitor I took out on this diagram doesn't match perfectly. Right here maybe? It was laying in this way. From that pin to ground. There's no capacitor in that position. So I took it out of, it was connected right over here somewhere. That's it right there. So it's a 20 at 25 volts, and when I see it, it looks like 50 at 50 volts is what I see written on it. 50 could be 20. 20 and 50, that's a fairly different thing. Let's look at this in the schematic. You should be able to find the 50 pretty easy. Well, oh boy. 50 electrolytic. Are they showing electrolytic special way? Ooh, that's a 50 right there. No. C50, 16. No. There's a 30 there. 50. They don't draw these capacitors any different. What was the number on it? The number's on it down here. The number is C52. C52. Okay, let's see 52. C52, 25 volts. So there it is right there. What's he up to? He's on the cathode. Cathode bypass. Bypassing this resistor. Bypassing what? Bypassing this thing down here. So, so 20 is plenty. 20, 25 is probably plenty. 20 at 25. Because typically the bias in this position, oh, wait a minute. Yeah, cathode bypass, Jim. Keep your head together. Okay, well, we'll just put in a big guy at 25 volts. 20 at 25 volts. Okay, good. Okay, I've just been clipping right along here, getting all the capacitors changed. So I haven't done any down here, but I've done all the capacitors up here. All the older ones. All the unreliable ones. That's the electrolytic one I put in right there. And just taking a look, we're going to start this guy up and see if it still works. Not with that like that, we won't. Okay, this is good. That's in. So there is another capacitor up here. It's inside this metal shield, which is screwed right to the side of the radio. So in here is a capacitor. Now, a couple of weeks ago I did a radio very much like this one. Another Westinghouse had exactly the same arrangement. I replaced it with an external capacitor just floating through the air. Now that radio, when you turn the volume way up, has a bit of a hummy buzz in it. Well, you have to have the volume right up, so that's the only time you'd hear it. I think it's because of this. So I'm going to do first stage, leave it. I'm going to leave that on the basis that it's probably not as bad as all the others because it's inside this heavy metal shell. And leaving it alone might be my best approach on this one. For now, anyway. Let's. So other than that, I think I got rid of every paper capacitor. Sometimes they hide them way down in there, but I don't see any down there. Thank you, thank you. Yep, there's none left. Let's start this thing up, and then I can probably call it a day here. So once again, power supply on standby, so it warms up. Okay, we're gonna hit the power here. It's gonna energize tube heaters. As soon as I just neaten things up a wee bit. Okay, heater's on. Let me just verify that. Yep. Speaker on. B plus at the ready. Volume down. And volume down over here. My little amp. Away we go. B plus. Going up. It would appear that the current leaking in the radio is way lower than it was, because I'm up around 150 volts here and I'm getting a leak of about 25 milliamps, which I think was 30 or 40 before. Could that really be true? My thinking is these leaky capacitors are leaking tiny amounts of current. So let's. I'm not hearing the radio either. Why is that? Because I'm at enough B plus. Boop! Something going wrong. Volume up. Something's going wrong. Connection made. Okay, made it to a little bit of a different spot here, but it's really the other end of the same cable, so this should work. Uh-oh. Let's just check and make sure B plus is getting here. Okay. Yes. Why are you so silent? Why are you completely silent? Oh, because I didn't turn up the volume. I turned up some other thing over here. Here's the volume. Oh, too bad. It's turned up full already. Well, this is a bad sign. Definitely a bad sign. I'm really against shotgunning capacitors. I didn't think I was really doing that here. Now, before this thing was dead and I just touched a particular spot and away she went. Let's just make sure we don't blow our ears off here. It was this spot. B plus on the meter. There was something else I touched that would make noise. Where was that? Where was the noisy thing? It should be noisy touching this. Nothing coming out. Why? This is so quiet. Why is my speaker so quiet? Could it be that moving this to another spot on the other end of the same wire and not make connection here? Yeah. Is it grounded? Maybe it's grounded by accident there. Okay, hold on. Volume rate down. I don't think so. Let's put it where it was before. No, it's just the other end of the same wire. Oh, I got to get in right past the B. Yeah, I'm not going to do that. That's B plus sitting right there. I'm going to push this clip lead in with my fingers there. No. No. Go back on. Back on here. Radio, why did you go quiet? Why have you done this? This is quiet. Oh. And nothing was wrong all that time. Got a little bit of action there. So the radio is really quiet, but that's because it doesn't have any antenna, maybe. So I will give it an antenna. Give it the antenna. Turn it down. Turn it down over here too. And the antenna. So there's a short on this 1 and 2, and I read something about that. I think you unshort these to hook up a loop antenna. Otherwise, they work as one terminal. Okay. I think that's the case. I don't want this ground falling in the radio. Just hang there, please. Volume up. Ah! Volume up over here, too. Oh, there we are. As crummy as that sounds. We gotta go all the way up. Don't like it. Don't like what's happened here. Not happy about this. So I'm just looking over every capacitor I installed carefully. See, there's something obvious that has occurred. I don't see anything. Ah! Let's just change bands here. Yes, a little desperate at this point. Volume. So the band changing isn't making a sound. It's just so something has gone terribly wrong up in here. Terribly wrong. What would it be? Well, how did that happen? How did that happen? Oh my gosh. Well, I think I'm going to leave it here, though, for today. Done enough damage for now. I come in tomorrow and continue with more damage on the radio. So we'll sort out tomorrow what has actually happened. Get it running again before I carry on further. Hey, thanks a lot for watching.